So good day, ladies and gentlemen. My name is Bella. I guess you have already learned a lot from the presentations before from Mr. Jason's. Now I plan to extend his presentation to focus on the new modes of smart city development using BIM and GIS. I think the topic may bring up a number of questions from you, and I will try my best to address as many as I can. And you can just put your questions on the Q&A chat box, I think, and the assistants will answer the questions after these presentations. All right, so this content is divided into 4 main parts. Initially, I will introduce to BIM and GIS technologies. Then we will focus more on the city information modeling. And the last 2 parts will be sharing on typical applications which use BIM and GIS integrations and also the use cases. Now let's begin with the first part, which is the BIM and GIS technology. First, let me show you what is BIM or what is BIM. As we know, BIM stands for Building Information Modeling, takes the relevant information data of building areas, and it records the geometric and also attributes information of building components in detail and accurately, and present it in the form of 3D models. And we have 3 primary aspects of BIM. The first one, some BIM design software have created data structure in their software. Let's say those BIM design software are Autodesk, Bentley, and others. Data and file created by one vendors is normally may not work in other vendor applications or in other vendor solutions. And to achieve the interoperability between applications, an open standard for sharing BIM data among different software applications have been developed. Therefore, BIM can be used for the entire life cycle process, starting from planning, design, constructions, and until the maintenance stage. And if that's the case, we also should know that the deficiency of BIM applications also bring up some issues. The first issues, if there are many kinds of BIM modeling software which has inconsistent data format. And the second issues, BIM only focuses on the management of the whole life cycle of the building, but lacks of the surrounding macro-geographical environment. And the last issues, BIM only focus on the design and constructions, but it lack of late operations, maintenance, and also the management. We will discuss these issues one by one on the following slides. So let me repeat again that for the entire life cycle of BIM, targeted for the fine model of BIM monomer, but it cannot be separated from the surrounding macro-geographical environment elements. And we know GIS has been committed to the research of macro-geographical environment, providing a variety of practical query and also analysis functions, while providing location services and also some spatial analysis. And in the operations and maintenance stage of BIM, GIS itself can provide decision support for it. So BIM needs GIS because GIS can make BIM change from micro to macro. Okay, now let's talk more about the cross-border integrations of BIM and GIS. So BIM is used to integrate and manage the information of the building's whole life cycle. You can see on this figure that BIM starting from design, planning, and constructions, while GIS is used to integrate and manage the information of the building's external environment. BIM and GIS have a natural complementary relationship because for the 3D GIS, BIM data is an important data source of 3D GIS, which can make 3D GIS move from macro to micro and also realize fine management at the same time. On the other hand, the integrations with BIM data makes the 3D GIS move from outside to indoor, realizing the integrated management of indoor and also the outdoor. All right, but now it brings up to questions on how to import BIM data into GIS platform. Basically, there are two ways on importing BIM data into GIS platform. It uses exporting plugin and also natively reading the BIM data. GIS software uses export plugins and also the conversion tools to achieve a close connections of geological and GIS data API, laying the foundation for the geological and also GIS integration applications. And this is some illustrations how to import BIM data into GIS platform. And now let's take a closer look on how is BIM model represented on GIS platform. So in this market, there are many BIM softwares, but the file formats are basically different. And in order to break through the bottleneck of BIM data access to the GIS software platforms, GIS software has developed the data export plugins for BIM software, such as Bentley, Autodesk Revit, Dassault, Tekla, Autodesk Civil 3D, and others. And meanwhile, it supports import the interchange format like IFC, and also we have the CTGML and others. Some GIS software also has a deep strategic cooperation with some BIM-related companies. So now it supports also the direct opening of some related BIM data in the form of database or data sources. And currently, the close connections between BIM and also GIS data can be achieved. All right, so this slide is basically showing the BIM data display in GIS platform. So it is using the natively reading BIM data. By using these tools, we need to ensure that we have a lossless effect while importing the data. And also the features of BIM are still need to fully preserve after we import to GIS platform, such as the data structure, storage form, and also the expression effect, because it will provide a strong support for BIM application in GIS platform. And these figures are some examples on importing many kinds of BIM data from different BIM design software, such as on the left top corner, we have the CATIA, and also we have the Revit on the right top corner, and also IFC and SketchUp data. All right, so this is another questions raising when we are trying to integrate BIM and GIS together. The question is how to carry the massive BIM data, because we all know that BIM data normally or basically has massive size of the data. There are some methods to optimize the performance on displaying massive BIM data. The first one, we can use the LOD or level of details technology provided by the GIS platform. It is to determine the resource allocations of object rendering according to the positions and importance of the nodes of the model in the display environment. And also it reduces the details of non-important objects so as to achieve efficient rendering operations. Suggest, for example, when the 3D scene is zoomed in, the model presents a very fine performance. But when the whole scene is viewed, the model only needs to be displayed in a rough way, which maximizes the occupations of resources, and also it improves the performance of the whole performance of the whole 3D scenes. And the second one, we have the instance mapping technologies. So as shown in this figure above, there are a large number of the same door objects in a house model, for example. Sorry, this one cover my, okay. Okay, and the instantiation rendering technology or instance mapping technology is used to save and draw only one object, which reduces the pressure of GPU and also RAM, and improves the performance of 3D scenes. And GIS Platform also provides a variety of BIM lightweight and triangulation network operations, including extracting shell, such as like shell and internal separations, triangulation network simplifications, sub-object simplifications, such as deleting the repeated vertex, computing, and also model splitting, model merging, and many other practical functions. And these two projects are showing an example on implementing BIM lightweight operations, because we could also see on this figure or in these slides, the size of this BIM model is very, very big. And this technology, the BIM Lightweight Processing, can help to enhance the performance on displaying the 3D models, 3D BIM models. All right, now let's take a look on some operations which can be done if we integrate BIM and GIS technologies. I will show you some capabilities of GIS Platform to provide BIM models editing, group management, component query, and so on. Okay, the first one, we have two figures on this slide. The first one is edit sub-object, and the second one is edit texture. So in GIS Platform, we can perform editing of the imported BIM models. Suggest if we already import the BIM models into GIS Platform, we still can edit the sub-object, like moving. We can move a sub-object of the BIM models into different locations using the model offset functions. And also we can edit the texture of the BIM models inside the GIS Platform using the edit texture function. And this is another capabilities inside of the GIS Platform. The users can check the BIM models information for each object to see the attributes or the properties inside of the object in BIM models. For example, we can see the attributes informations inside the desk or inside the chair object or any other object inside the BIM models itself. Next, BIM models, after being imported to GIS Platform, it also can be grouped for better organizations. You can see on these figures on the layer management here on the left side. This is the layer management or on Supermap iDesktop. And in this layer management, the BIM models are being grouped into different sections. And this one, I have one video. It's showing the overlay BIM models and also a base map and oblique photography. So basically, these BIM models can be queried by the attributes. For example, if I want to query only the window object, and if I want to query the building on the first floor, and after the process finish, the model itself will show the object which location in the first floor. Or if you want to query and display any other object inside of this BIM models, it also can be done. Okay, and here we have also another capabilities, which is the box section view. So here we have the BIM models, and in these BIM models, we can also display these models using the cut sectioning view. Specifically, it's the box section view. So we draw a box for the cut sectioning to see the model inside of this box only. All right, and in the GIS Platform, it also can provide the dynamic simulations function by setting the display and hiding of the BIM models. In practical applications, the process of building constructions, it can be simulated and the building production can be viewed based on the construction progress and also the time schedule. All right, so we're moving to the second outline, which is the city information modeling. After showing the capabilities of BIM and GIS integrations, I think we can discuss about the city information modeling. But before that, let me show you these illustrations. I have a city environment overview here, and I have some issues that I want to share to the audience here. And these issues are starting with the questions, how if. How if I want to place the BIM models at the actual geographic locations? And how if I want to analyze any conflict of pipeline assets? And how if I want to understand the surrounding area of the building? How if I want to build bridges and look at aspects related to that land? How if I want to query and analyze the building for assets management? How if I want to manage the underground assets in my city? How if I want to link objects? How if I want to manage multi-source data fusion? And another how if. And basically these questions can be answered by using the city information modeling. Because you can see on this slide, BIM GIS can play a greater role in the city level. Because building are cells of the city, and BIM and GIS, BIM integrate with GIS, can manage the cells, as well as the environment around the cells, and various connections network to make up the CIM or the SIM. City information modeling itself is an organic synthesis of 3D urban spatial models and urban dynamic informations, forming a comprehensive urban information management platform, including the BIM, geospatial data, Internet of Things data, and it is the future development trends of BIM plus GIS. And based on the CIM, or based on the city information modeling, we will promote smarter cities to a higher level. So the data types involved in CIM are diverse, including BIM, and also here on this video we see the oblique photography, and if we have the laser point cloud data, it will be great, and also the image data, vector, real-time dynamic IoT data, and etc., which needs to solve the problems of multi-source data integrations and accurate matching, unified management of those multi-source of data. And the GIS platform can provide SIM with data access, integrate and matching management and analysis, as well as high performance rendering and multi-terminal display of massive urban data. And here we have the BIM model expressions and capabilities. BIM model as expressions of 3D solids have some capabilities. For example, the first one is 3D spatial relationship. The judgment of 3D spatial relationship refers to the judgment of the relationship between 3D models, including intersect, contains, and etc., to realize the query and also retrieval of 3D models. Next, we have the 3D spatial operations. It includes intersections, union, difference, and etc. And then we have we can also perform the 3D spatial analysis, includes viewshed analysis, domain analysis, shadow analysis, skyline, openness analysis, profile analysis, slope analysis, and others. And also it can perform the 3D measurement function, such as spatial distance measurement, spatial area measurement, elevation measurement, and others. And here we have also the reduced dimension or a dimension reduction calculations. So it refers to data dimensional reductions in a certain way, including the plane projections, arbitrary sections, and elevation projections. And the last one, we also provide the 3D printing technology inside of the GIS platform. So your BIM models can be exported to the 3D printing format, which is normally has the extension file as the .stl. Okay, and this one in the CIM, as we understand earlier, we need to match multi-source format data. It also includes to match BIM data with multi-source. With multi-source data becomes particularly important. In this figure, it shows that BIM can be integrated with 3D tint data, with the oblique photography, with the video matching, and also with the water effect. So in some GIS platform, we have the water effect function. Here's to display better visualizations. All right, and in this slides, it's basically showing an example of SIM platform or same city information modeling platform based on the BIM and GIS engine. So you can see here on this figure, the BIM model is overlaid with many kind of data formats, and it displays the real 3D scene. Yeah, sorry, and display the real 3D scenes. And inside this platform, we can also perform some analytic functions. So it looks like a dashboard, but using the input data as BIM and also other 3D model data. So there are many typical BIM and GIS industrial solutions and also application cases, including the urban and landscape planning, architectural design, 3D cadastral maps, indoor navigations, and so on.
Well, I'm sorry to interrupt.
Sorry,
you still have 5 minutes, yeah?
All right, thank you, Mr. Made. So where actually BIM and GIS is applied, BIM and GIS is applied on the entire life cycle of constructions, including the planning stage, design stage, construction stage, and maintenance stage. Let's discuss one by one. So the first one is planning stage. Let's take a closer look on it. So the planning stage can include the site analysis, which provide the evaluations of site condition and characteristic. And the second one, the architectural programming. And the last one is project demonstrations. So it is necessary to combine the 3D GIS and put BIM in the big scenes, such as oblique photography, to demonstrate and also compare the architectural schemes. And this is the implementations of BIM and GIS in planning stage. So we have the urban design refers to the design and organizations of urban external space and physical environment for specific urban construction goal. And it can provide strong capability of multi-source 3D heterogeneous data integrations and 3D data operations, also analysis ability, flexible rule customization ability for the urban design, and also beautiful scenes and provide services for urban design. And the next stage which can apply BIM and GIS is the construction stage, because using BIM and GIS, it can perform construction schedule simulations and construction organization simulations. And this is one of the projects which implement BIM and GIS on the construction stage. It breaks through technical difficulties such as precise matching in centimeters between BIM and also GIS data and real-time rendering of million-level BIM models. And the last stage which can apply BIM and GIS technology is the maintenance stage. So I'm showing you one of our projects which implement BIM and GIS in the maintenance stage, called as BIM Operation Platform. The Operation Platform of Shanghai Center, developed based on the SuperMap GIS platform and integrated with many kind of data. I think I'm going to show you more details on the video on the last slide. So we will skip this one first. And this is another project which implement BIM and GIS in the maintenance stage. It is the River 3D Visualization Information Platform. So SuperMap has been involved in this project for the whole life cycle of hydropower in river basin. And we have also road and bridge management information system. All right, so now we have arrived at the last part of these presentations. Mostly I'm going to show you some project video which implement BIM and GIS on this part. So the first one is Shanghai Center, we already mentioned before, but let us discuss more details on this project. So this project is for Shanghai Center. It is the second tallest building in the world and the tallest building in China. So the implementations of the Shanghai Center project is extremely difficult because it was the first time that China built a skyscraper of more than 600 meters. And the building has a total height of 632 meters and 121 floors above ground. So with such demand, a super tall building like Shanghai Center will naturally come across various challenges during the management phase. So here we, in this project, we have the operating platform. We can do the floor queries. It can be made and we can choose different model system in that floor, such as water supply, heating, security system. And in each system, we can click to view the KPI information of independent devices or search or locate them. And this platform is also equipped with emergency management as well. It performed the fire emergency actually. And at the same time, the platform can showing the working conditions of emergency equipment. And the next one is Planning Department of Hong Kong Online Planning and Design stage. In this platform, we may see a real 3D scene of the city by combining BIM GIS, oblique photography data, and other 3D multi-source data integrations. And we can also perform the urban planning analysis, such as planning scheme reviewing and other 3D analysis. So this one is skyline analysis, one of our 3D spatial analysis. So we can review the city skyline, whether it is open or too many high building covers the skyline. So this is the last slide I want to show you, and this is a video. I hope this video can be smoothly displayed. So this is the GeoDesign platform for town and planning in Hong Kong. So we have the BIM models. We can display it as project in the web-based applications. And we can also overlay with base map and also orthophoto if we have it internally. And we can also perform the 3D building GIS. We can also display the 3D building GIS layer and also do the query building attributes. And it also can be overlaid with high resolution photo, realistic city mesh models here. And here inside of the oblique photography, we can also display a BIM models. And we can also do the split screen to view the design BIM with mesh, to view the before and also after we import the BIM models. And also we can open the terrain layer and show the underground of the 3D utilities with BIM and mesh, and show on off inside of the BIM models itself. And do the query for the attributes of the BIM models. Actually, this video is still long to go, but it seems my time is already finished now. So I think this is my presentations. Thank you for your time for watching my presentations. I hope you can get a better idea on how to implement BIM and GIS in the smart cities level. So thank you.